Yeah, good morning, sir.
Good morning. From today, we're going to start with SAP BW powered by HANA, or you can say BW application running on SAP HANA database. As part of this topic, we're going to deal with HANA optimized cubes, reconverting of HANA optimized DS. Then we're going to deal with how do we consume HANA models in the BW, and how do we import BW objects into HANA. Then we're going to deal with operational data provisioning using ECC as a source, SLT or HANA views, advanced DSO, OpenODS views, composite provider, and then how can we implement HANA-based transformations by using ABAP managed database procedures, NLS, nearline storage. Then we have a concept called analysis process. Then we'll deal with LSA plus architecture. Then we also have database migration on HANA. So if you have your BW system running on non-HANA database, how do we migrate this database from non-HANA database to HANA bus? That's what we're going to deal with as part of this topic, database migration on HANA. Okay. Now, first one, HANA optimized info cube. So when you have when you say BW running on HANA, it is this. I'll mute. One second, disconnect. Okay. When you say BW on HANA or BW powered by HANA, normally whenever you install BW, first you install the OS, then you install the database, then you will install the ABAP stack. Okay. Now from BW 7.3 SP5, we have the flexibility of installing BW with HANA as a database. So you'll have your OS, then you will install HANA database, then you will install BW on top of this HANA database. So it will be like you'll have BW application with backend as HANA database. With BW with backend as HANA database. So I have this server. Now, when you look at this BW system, when I go to the status, it tells me the database system is HDB, which is HANA. And which database is it? SP9 is a system ID, 01 is the instance, and this is the host, HANA server name. Yeah, this is what it is. Now, if I go in, okay. So this is my HANA database with this SP901. This is my system, SAP Cubex. So this database is actually the backend database for my BW applications. And now we have something called owner here, SAP ABAP. With this owner name, you should see a schema, SAP ABAP 1. So this schema is considered to be the BW schema, means like all the entire database, whatever you could see in SE11, all the database tables. In the entire database, you can view it from, so I just take some table. So I have this table out. Okay? The same table can be seen in this schema here. You can see this table here. So this will be called as a BW schema. So when that is a owner, in the BW application, whenever you create any of your info providers, any of your database, whenever you create your BW objects, the corresponding database objects like F table, active table, whatever it is, will be created automatically into your BW schema. So that is what we can refer it as the owner here. Sorry, it got disconnected. Okay. That is what we refer it as BW schema here. And one more point is, if you go to the T code DBA cockpit, you can see the detailed information about the DB connection and what is. So you can see the system name, the connection, the DB user. See, you'll have a schema with SAP ABAP 1. You'll also have the user with the name as SAP ABAP 1. So whenever your BW is trying to do something into the HANA database in the backend, it always performs the work based on this user, SAP ABAP 1. For example, you create a DSO in the BW system. So it has to create relevant tables in HANA database. For creating those tables, it does use this user as user to connect to the database. You can say test connection. So this will be the primary database connection from BW to HANA. Says it's all fine. So you should know that you'll have a BW schema, and with the same name you'll also have a user ID who actually takes care about manipulating all this database in this BW schema here. Yeah, you'll have the same name. That's what it refers it as owner here. You'll have a user and also schema with the same name. So whenever BW is trying to do some operations onto HANA, it does use this user ID and this particular schema with the same name. So we call this as BW schema. So all the BW relevant database will be created under this schema in HANA. Okay. Okay. Now let's move on to HANA optimized InfoQ. So with BW on HANA, like we had InfoQ already, but we have some concept called HANA optimized InfoQ. If you look at the general schema, you'll have F table and E table. You'll have two fact tables connected to your dimension tables, and each dimension table getting connected to the SI tables and the corresponding master database, right? So that is how you won't have the normal, the old star schema of the normal cube. So you'll have F table, E table connected to your dimension tables, and dimension table connected to your SIDs, and SIDs connected to your master data objects. So if you actually understand the importance of the dimension table, if I have the SID table directly into the fact table, we could only bring in 16 keys and we could connect only to 16 SID tables. To enhance that, what they've done is they've brought in a dimension table. So, and each dimension table could be connected to with 248 characteristics in it. So what SAP has done is, once we have the HANA coming in with BW, so we have something called HANA optimized schema, which will be different. You'll have no more E table, you will just have only F table and connected to SI tables directly, and the SI table will be connected to your master. No more dimension tables. In the star schema of HANA optimized scheme, you will not find dimension table, but there will be only one dimension table created, which is your data packet dimension. Others, there will be no dimensions at all. And straight away they will be connected to the SI table and there will be only one table, one fact table, which is F table, no more E table. Only single fact table, which is F, which will be connected to the SI tables directly, and SI table is connected to the master tables. And you still have one dimension table existing, which will be your data packet dimension. That is your HANA optimized star schema bus. Okay. Let's see that and then. Okay, I have the info areas. Okay. I would create an HANA optimized cube, create cube. So I have a DSO existing, which I would like to take that as look at this. By default, we're creating a normal cube, normal standard cube, which is specified as HANA optimized. So whenever I create a cube in BW or HANA, by default it will be HANA optimized info cubes. So by default it takes this. You can basically segregate it to different dimensions. See, even though dimensions do not exist physically, while creating cube, here you see standard cube, SAP HANA optimized info cube. Okay, this will tell you that it is an optimized cube. Don't worry on these two. I'll come back. The next I have this dimensions. We still see the screen same way, having dimensions, and then you assign characteristics to the dimension. Right click and then you say assign, and then you put all those same way. But even though you see a dimensions here, they don't exist physically. This is only for organizing your objects. Even though that has been used for organizing, still the limitation of 248 characteristics max per dimension still holds good. But even if you see a dimension, they're not physically created except the data packet dimensions. Okay, I can put some time characteristic also. There's key figures. It's all fine. I don't do anything now. Dimension tables. Okay, active. Now this is about having creating this unoptimized cube. There's no difference. But when you analyze those tables, now I should have the tables created in this schema, be SAP ABAP one. It's a cube 99. I have two things. One is /BIC/F cube 99, which is your fact AF table, /BIC/D cube name P, which will be your data packet dimension. So it does create only data packet dimensions. So when I see the fact table definition, so it will have, first is your dimension key for data packet, and rest all you'll have the SIDs of the characteristics connecting to the SI table of those, and you'll have the key figures. And data packet dimension is common, it's straight away same. You'll have a dimension key and record ID, record type, and request ID. So what SAP feels is even though if I will load 1 million records to the cube, all 1 million gets loaded with one request ID. So generating a request ID for all 1 million does not really take a lot of time. So they still wanted to have the data packet dimension ID process. Okay, this is one point. And one more point is, if you go to runtime information, by default, the fact table will be is created with 4 partitions with round robin, 0, 1, 2, and 4. If you expand, you'll have 1, 2, 3, and 4. By default, the F table of a cube is always partitioned based on, and one more point, it will be a column store table, a fact table, all tables almost. And it will have a round robin partitions created with 4 partitions, 1, 2, 3, and 4. And see, basically, when you have 4 partitions, and will you have E table was? No, right? If you remember in the normal cube, normally when you load data into the data into the cube, it gets into the F table, and when you compress, data from F table is moved to E table. But in case of unoptimized cube, you don't have E table, right? You do not have any E table. But the question is, will you still do compression in this cube? Do we still have compression concept? In the new HANA optimized cube, we do not have the E table, but do we still have the compression concept? Yes, we still have the compression concept. But how does the compression concept work out? Yeah? So every time the fact table is created, it will have round robin partitions with 4 partitions in it. And when you initially load your data into the cube with the DTP, all the data is will get loaded to partition number 4. So partition number 4 will have the data what is loaded into the cube. Then if you are compressing that request, so it deletes the data packet dimension, then aggregating records based on the other SID not dimension ID now, SID key combinations, it aggregates those records. After compressing, it puts the compressed data in partition number 1. So indirectly, it is using partition number 1 as E table and partition number 4 as F table. So when you load the data into the cube with the fact table, through the DTP, it loads all the data into the partition number 4. And when you compress, the data from partition number 4 is moved to partition number 1. While moving, it deletes data packet dimension and then aggregates the records based on other SID combinations and then puts into partition number 1. Then you have partition number 2 and 3. Partition number 2 and 3 will be used only in case of non-cumulative cubes. Okay. When you basically load the initial stock, that will be updated into partition number 3, and all the movements will be into 2. For example, when you load data into the non-cumulative cube, first data gets into 4. When you compress the cube with marker, the data gets into number 3, the opening stocks. When you compress without marker, it keeps loading the movements into partition number 2. So like this, it does use 2 and 3 only in case of non-cumulative cube. And 1 and 4 is used in case of normal cubes. Okay, like this you'll have 4 partitions, 1, 2, and 3, and 4. Okay.
Sir, I have one question here, sir.
The normal cube migrated to HANA. I'll come to that, Anil. I'll come to. Yeah. What is it?
Sir, if you see the table symbol here in the left panel, table symbol.
Yeah.
For dimension table, it is like 1. In fact
See,
table, it is like
this symbol
2.
indicates this table is partitioned.
Oh, okay.
Yes, you see a
Okay,
space, it means the tables are partitioned. Okay. I'm telling right. A fact table is always partitioned with round robin with 4 partitions. That's the symbol indicates that. Okay.
Okay, sir.
So once,
Sir.
let me just finish one round, then I'll come to the discussion. Yeah. Yeah. Let me just finish up this. Let me show you that loading part and then. I want to go with full so that I can load data multiple times. So I've loaded 5 records. If you see, you will see those 5 records in the cube. Fine, but in which partition you will see those? In partition number 4, you see this 5 record. Look at the count here. In the record count column, you see this 5. Yes. Now I'll go to my cube, and it's not flat file. It's a DSO. So I just want to compress this cube. Request 553. I'll go to collapse. Select the request ID 553, and I'll set it. Compression concept is same. It is going to delete the data packet information, request ID, then aggregate the records based on the SID combinations. And the compression concept, the logic of compression is executed as a stored procedure in HANA, so it will be very fast here. My compression is done. If I go to my cube now, if I refresh, see where is all my data in now. So do I see? If you look at partition number 1, I've got those 5 records, and partition number 4 has got 0 records. And if I try to see the data, you will see no request type. Data packet dimension is 0, and then it's aggregated. Suppose if I load the data again, if I load the data again, you'll have 10 records, but the new records are with another data packet dimension packet. One, two, this is 5. 5 indicates 554 is my request. So 554 is request ID for this. Now you should see 5 records in partition number 4 and 5 records in partition number 1. In partition number 1 you see 5. In partition number 4 you see 5. Okay. Let me compress this queue. You remember, I'm just loading the same data. So generally when I compress, the record should get aggregated, right? And the compression is executed as a stored procedure within HANA bus. So after compression, this 5 records will get into partition number 1. Why do I see only 5 records in the partition number 1? Because it's same records, the SID's combinations are same, it aggregates.
Updated.
Aggregate, okay. So I see 5, so all the 5 records in partition number 1. So before compression it will be in 4, after compression it will be in 1 bus. Okay. Clear with this now? So this is about compression. Now question is...
Sir?
One second. Let me finish first. You'll have slight confusion, don't worry. Now question is, I am compressing this cube, right? So in previously when we never had HANA, our concept of compressing a cube was for what? For what was it we doing it? Previously,
To avoid space.
avoid space, still more perfectly to improve query performance, right? Our major concern was about
retrieval access.
improve the query performance, yeah. But now we said with HANA as a backend, you store data in any detail, it can handle the performance, right? We said since it is a column store table, you store data in any detail, system can handle the performance on it. We don't have to really compress data further, right? So the point to be noted is, in case of HANA optimized cube or in case of BW on HANA, compressing of a cube it might improve performance very minimal, but compression of a cube is not for improving your query performance bus. We do not compress the cube to improve query performance, because even though data is in detail, your HANA system should be able to handle the performance out from there, right? So the question is, why should I compress the cube? Why should I compress the cube? Now look at this. Within the DDP, So within the DTP, when loading into cube, we have a checkbox here, trigger database merge. Since the backend table of a cube is a column store table, so when I say column store table, it will have the delta table, main table. Remember the delta merging concept? So if you have 4 partitions, each partition will have main table, delta table, main table, delta table, and then merging. Yeah, merging is writing data from delta table to main table. The point here is we actually compress the HANA optimized cube to improve the performance of delta merge, not the query performance here. Now, for example, say I have partition number 4. Let's say you load 1 million records. So all 1 million records will be in partition number 4. Then when you have this checkbox enabled saying perform delta merge after loading, after the data is loaded to the queue, it performs merging. So does it do merging for all the partitions or only for partition number 4? Since there is new data set inserted into partition number 4, it performs merging only in partition number 4 with 1 million records. Say tomorrow again you loaded 5 million more. So again, since there's new data set in partition number 4, again it does do merging on only partition number 4. With how many records? 1 million previously and now 5 million. So total it performs merging on 6 million records. So the time taken to perform the merging on the partition number 4 will be more because of 6 million records. So you have 6, again you load 4 million, again you do merging, again it performs merging only on partition number 4. Again it has to do merging for 10 million records. So it will slow down the merging process. And if I have done this way, I take the first 1 million from partition number 4, compress it takes into partition number 1. Then you load 4 million records. Again, the 4 million comes into partition number 4. Now, when you compress, what happens? It when you if you do merging, it will do 2 mergings parallelly. One at partition number 1 and one at partition number 4. For partition number 1, it performs merging with only those 1 million, and the partition number 4 it performs merging for only those 4 million. So this will improve the performance of your delta merging operation on the fact table. So that is the main reason of doing compression on the cube. It is not because of improving your query performance. Okay. Now tell me what doubt do you have? Hello, boss. Any doubt?
Hello?
Yeah.
Yeah. Yeah.
Yeah.
So when you created 9 qubits, how does data has come into that table? I mean, we did not give any specific definition of the table, right? I mean to say, when you try to give, create a table, we try to give the metadata, right? Like it is integer, decimal, something like that.
Yeah.
But we never gave anything, but it has come all the field. Yeah, as you could see that, SID.
While creating cube, I defined this. I defined my columns, and these columns already have those properties. Yeah.
Sir, what he mean to say is we didn't drag and drop those dimensions.
Because
from, let's say, we need to drag and drop, right?
I used copy from, so it automatically takes those fields from different data object.
So you mean to say demo HANA optimized cube already has a copy of something, so that we used for creating 9 qubits. Is that?
There's already a cube. I just copied.
Okay, which is named as demo HANA optimized cubes.
Yeah.
Okay, yeah, that's fine.
Sir, now even though if you create, is it possible to create dimensions here in the cube?
Yeah, you can create.
So even though if you create internally in the backend, it doesn't care about dimension type.
What are the dimensions you create? It just only for organizing. Internally, it doesn't.
Yeah, just for okay. Just for display purpose, it will arrange.
Exactly, but still the limitation of 248 per dimension is still there. Yeah.
Okay.
So we are doing compressing cube because to improve the performance of delta merging. Because you don't compress, all your data will be in partition number 4. The data the size of records will be huge. So performing merging on all those records will take a lot of time. So we are just splitting out records to other partitions so that it goes to partition number 1. then when you basically compress it, it only compresses on, when you do merging, the merging is done only on the new records what is loaded, not for all the records. Yeah.
Sir, when we, sir,
Yes, please. Yes, yes.
yeah, sir, when we compress the fact table, data has been loaded from partition number 4 to partition number 1.
Yeah.
So in the partition number 1, it might be loading to uh, delta storage, sir.
No, no,
Delta storage
no, no.
table.
See, you have partition 1, 2, 3, 4, right? Partition number 1 will have main and a delta. Partition number 2 will have main and a delta. Partition number 3 will have main and a delta. Partition number 4 will have main and a delta. Okay. Now we have some new records loaded to partition number 4. Where will those records go? Those records will be written to your delta table. Then when you have merging done, the data from delta table is written to what? Main table of what? Partition number 4. When you do compression, the data from the main table of partition 4 is written to main table of what? Partition number 1. So now even if I do delta merge now, since there is no data in the delta store, the merging is done faster. Now let's say again tomorrow you load some new set of data to partition number 4. Those new data will be in which block? Delta store of partition number 4. Again when you do merging, now it has to do merging only on those records only, which is newly loaded. And if you have not performed the compression, my old records and the new records, everything will be in the delta store, and then it has to do merging for all the records every time. Right?
Okay.
The number of records on which the merging has to be done will be huge.
Right, right. So, sir, what I understood is it is loading directly to main table of the partition number 1.
Yeah, because it is already, it's a main store, right?
Okay.
Yeah.
So, sir, in that case, generally the main storage table is optimized for reading but not the writing, right?
Yeah, yeah.
Is that okay? Is that okay performance point of view? That's okay?
That's what I'm saying. I'm asking you to do merging, right? Only when you do merging, the data is returned back to main, right? If you don't write it to main, you'll have huge amount of data in the delta bus, right? Which is not optimized for reading. Then the performance might be bad, right? So every time I'm loading into cube, I'm doing a merging so that the data from the delta is returned back to the main, and my performance of reading is good.
Right, sir. Right.
Yeah.
Thank you.
Sir?
Yeah.
Yeah, here we are talking about only, we have 4 partitions, right?
Yeah.
We are speaking about when data comes, it every time comes into the partition number 4, and when we does the merge, it goes to the first one.
When we do compression, it will go to partition number 1.
Yeah. Okay. So what about second and third? What kind of significance is second and third place in?
I told the second and third will be used for non-cumulative cubes. I think you're not a BW consultant. You're from BW itself, or?
No, I am new to the BW, so I'm trying to understand.
Yeah. So partition number 2 and 3 is mainly for non-cumulative cubes. Okay. So when you say non-cumulative cubes, if I have a cube which does not get cumulated, for example, yesterday my stock is 100 and today my stock is 120. My stock. So if I say what is my stock, you say 120. You're not aggregating it. So those kind of measures we call them as non-cumulative measures. So if I have a cube which is using those non-cumulative measures, we call that as non-cumulative cube. So when you're dealing with non-cumulative cubes, partition number 2 and 3 are used. Partition number 3 will be used to hold the initial stocks, and partition number 2 will be used to store the movements. Even in case of non-cumulative cube, when you load, data gets into 4. So when you compress with marker, the data comes into 3 when like initializing the stock. And when you're loading as historical movements, it gets into normal movements, it gets into 2. Okay?
Okay. Yeah. Thank you, sir.
Yeah. Once we create HANA optimized cube, fact will automatically be created in the tables folder of S. Every time you create a cube, it will create the corresponding the tables, F table or dimension tables in the BW schema in HANA. Yeah, you can see that in SC11, or you can see the table definitions in BW schema also. If you do compression, data will be moved from partition 1, and when we do merging on partition 1, when new set of data comes in, will it do merging on partition number 4. So when it writes to partition number 1, when the new data is loaded to partition number 4, so it does do merging only for partition number 4, not 1. That is where it is improving performance of merging bus. Once I do compression, the data from partition number 4 is moved to partition number 1, and now partition number 4 is blank. Now when you load new set of data for partition number 4, and since there is new data set only in partition number 4, it does do merging only for those records. So that improves your merging process. Okay. So the benefits what you get, I think you should be able to come out with.
So I have a question.
Yeah.
So when you say there is no dimension, it's only one dimension, it says that easy to move characteristics from one dimension to other dimension. How it's possible?
Even when there is data?
Yeah.
Yeah. Now
I mean,
I'm coming to that. Yeah. Look at this. So I have we have something called simplified modeling. Because of the new HANA optimized star schema, we'll have simplified modeling. When I say simplified modeling, easy to change the definition of the cube when there is data also. If you remember in the older versions of normal cube, once we have the cube created and the data is already loaded into it, can we still do the changes to the cube? Once I have cube been created and I've loaded the data into it, now can I do changes to it?
No.
Yes, we can do change. Yes, we can change it. We can do some changes, not all the changes. Let's say I was having flexibility of adding a new characteristic or new key figure, but I never had a flexibility of deleting a key figure or deleting a characteristic. I never had that flexibility when there is data. Right? We can still do. Now, in case of unoptimized cube, since we don't have dimensions, I can do that. I can delete characteristic, I can delete key figure, I can move from one dimension to another dimension, I can, because they are not physical, so I can move them. Yeah, I can add, in all remodeling is been simplified now. Okay. In case of unoptimized cube, you don't have to delete data if I have to delete my characteristic. For example, I already have the data loaded, right? I already have the data loaded in this cube. So I'm going to say change. I just want to remove the start date. Okay, I removed it because it's a column store table. It's very simple. That's it. Activate. I deleted an existing characteristic. Yes. Does it still have the data in it? Okay, only that column is removed. That's it. Okay. You just have end date. Now there's no start date now. Okay. Now, as you ask me, you want to move to another dimension. It's same. You can do any change. Okay. So not edit. I want to say create new dimension. Dimension 2. Now let's move this into dimension 2. Since they're not physical, it's easy. You can still do remodel. Okay, boss. This is what you wanted. So remodeling is being made very simple in case of unoptimized cube. That is one of the advantages you'll get. And again, when it's a simplified modeling, if you remember while designing, when you want to design a cube, without HANA, we had to do a lot of dimension analysis saying, like how do you decide what characteristics, since the dimension is physical in case of normal cube, we had to do a lot of analysis. Like when you want to design an optimized cube, we wanted to reduce the number of records in the fact table and dimension tables. So we always wanted to have in a perfect design, we always wanted to have the size of the dimension table should not go beyond the 20% of the fact table size, right? So then we used to do a lot of dimension analysis saying, what is the relationship between those characteristics? Is it like one to one or one to many, same dimension, many to many different dimensions? We used to do all those kind of analysis. But now, since the dimension table itself is not physical, There's no point in doing that analysis. Straight away, you just define the dimensions as just like folder and then just group them into different folders, just like for organizing, nothing else. So you don't have to really worry about any dimension analysis or size of the dimension tables here in case of unoptimized cube. That's where we have simplified modeling, easy to do remodeling, and now faster loading because we are able, in case of unoptimized cube, the loading is faster because we don't have dimension tables. We just have only the data packet dimension. Since when there is no dimension table, there is no concept of generating dimension. Straight away studies are put into my fact tables. So in that case, since I've eliminated the process of generating dimension IDs, it will speed up my loading process. But I know we still have the data packet dimension, but generating data packet dimension will not take a lot of time because even if you load 1 million records or 100 million records, for all the 100 million records, it just generates dimension ID only once. So that's where they say it is not going to affect your performance of loading for data. But with the data packet dimension, it gives you the flexibility of deletion of the data based on the request ID bus. Because if I don't have the data packet dimension, I cannot recognize which data is coming with which request. Having the data packet dimension will help me to do a deletion based on the request, yeah, and it does not even affect the loading performance because you just generate one request ID for entire records of the request. Yeah. See, advantage is to do very fast request deletion. See, there's one exception with request to respect to table layout. We still have a data packet dimension table for HANA optimized cube. The advantage is for faster request deletion, while the effect on loading performance to create package dimension is negligible because it does not take much time to generate that. Now the question is how it will connect to master data through SID. From SID it will connect to master because fact table it's like more like a line item dimensions everywhere. Boss. If fact table has got SID table, SID will be connecting to SID table and from there to master data tables. Yeah. Now question is, so now you know about HANA optimized cube. Now question is, if I have normal cube, how do I convert that to a in-memory cube or HANA optimized cube? Very, very important. Say I have a BW system. It's a BW MS SQL as a database in the backend. I will set up. This is my old BW system. And in this old BW system, I created my cubes. I've created a lot of cubes. So when you work with BW with MS SQL as a backend, and the cube what we create will be what? Is it HANA optimized cube or normal cubes? Normal standard cubes. Then later what you've done is you have basically migrated this BW system to HANA bus. Okay. So once you migrate your system to HANA, the cubes are still as normal cubes only. So once I migrate this system, which is running on SQL Server to run on HANA now, this is called database migration. Let's say I had a BW system running on SQL Server database. Now I've kind of lifted and shifted the database from SQL Server to HANA. Now it has become as BW is running on now as HANA bus. Now what happens to those cubes? So what are the cubes we have? They'll be as normal standard cubes. We'll have to explicitly convert those cubes to HANA optimized cubes. So now once you have performed the migration of the database from BW to HANA, from other non-HANA to HANA database on BW, we'll have to explicitly convert these cubes from normal cubes to HANA optimized cubes first. And how that is done is this. So we can either use this program rs_dri_convert_cube to in memory, or we can use this T code rs migrate HANA DB. Okay. Anyway, boss. See this rs_dir_convert_cube to in memory. I can run this program. You get to say the same screen, or rs_migr HANA DB. Ultimately get to the same screen. Here you just get in specify the cube name, and then you just execute. Now this will convert this cube from normal cube to HANA optimized cube. If you want to go with some set of cubes, you just click on this. You can say list of multiple cubes. You can give a range or exclude whatever it is and trigger that. And you're going to see the log. You can also see the log of migration. And yeah, just take this about the cube. Okay. But I cannot show you. Okay, let me tell you. Okay, this is fine. Okay. Now next question. That is one point. Suppose I give you a new system with BW on HANA. I give you a new system with BW on HANA, and the cube what you create by default it is HANA optimized. You don't have to convert or you don't have to migrate. You got this? See, if you've been given with BW on HANA, and the cube what you create by default it will be an HANA optimized cube. That's where, if you remember, I'm working on BW on HANA system. So if I just get in, if I try to say create info cube, by default the checkbox enabled as HANA optimized cube. By default it will be HANA optimized cube. So if it is a BW on exist HANA system, the new system, and the cube what we create is by default HANA optimized cube. Yeah. The next option I would like to go with this. Say understand this is development environment. Just assume, okay, this is quality environment. So development I've got BW with SQL Server database. Quality I've got BW on HANA bus. And let's say I create a cube in SQL Server database with this say normal cube, saying it is like not HANA optimized cube. This will be normal cube. When I transport this cube from non-HANA database BW to a BW HANA database, it is automatically migrated to HANA optimized. Because when you say transport, what happens? You're reactivating this cube. When the cube is reactivated, it gets created as HANA optimized. So when I transport a cube from a non-HANA database BW to a BW HANA database system, when I transport my cubes, during transports, automatically the system gets migrated as HANA optimized cubes. You don't have to reconvert again. Only in case when the system is migrated, say you have your build system which is running on SQL Server, the same system is migrated to HANA database. In that case, the cubes are still as normal cubes. Then you'll have to explicitly use the program RS T code, RS MIGR HANA DB T code or the program, and explicitly convert your HANA optimized cubes to, normal cubes to HANA optimized cubes. Okay. Okay, boss. And one more important point: before you convert the cubes to unoptimized cubes, make sure your flow is in BI7 flow. Because if you have 3.x flow, see, when you convert that into unoptimized cubes, or when you go into HANA, you're going to have it as column store tables. And if it is column store tables, they will need delta merging. Yeah. And delta merging is only possible to be triggered from the DTP bus. Suppose if you're loading this cube from 3.x flow, you cannot trigger your merging. So preferably when you're working with HANA optimized objects, you would prefer to have the data flow in 7.x data flows. Okay. Suppose if you have 3.x data flow, if you have a cube which is getting filled with 3.x flow, make sure you migrate the data flow from 3.x to 7 by using RS migrate. Complete flow has to be migrated. Then think about converting the cube as an optimized cube. Okay.
Sir, can I?
And let me finish up these 2 points. So see, during the conversion, there is no lock is set. You can still do reporting bus. Remember, see, even during the conversion process of this cube, you can still run reporting is still possible. But the maintenance activities like loading, deletion of data is not possible during the conversion. But even during the conversion process of the cube from normal cube to unoptimized cube, reporting can still go on. And but the data maintenance activities about deleting or loading, those cannot be done during the conversion process of the cube. And once the cube is converted as unoptimized, you don't have to reactivate any of the multi-product. It is nothing to be changed. Okay. nothing gets deactivated. So once the cube is converted unoptimized cubes, you don't need to change any of the DTP, load process, multiple, nothing. They will be just as it is. They'll do not get inactive bus. Okay. And this I told you about, okay, about partitions. So the partition numbers here, it's not correct. Actually, this is supposed to, partition number 1 is compressed. Partition number 4 is what? Uncompressed movements. Install stock or marker update. So 2 and 3. 3 and 2 are always used only in case of non-cumulative key figures. Okay. And now the question is, only when we have only one single fact table, but we still have the option of running. So even though there is no E table, you still have the option of running compression, because here the compression is executed as a stored procedure which will write data from partition number 4 to partition number 1. Compression is required to speed up the merging process, because this becomes only relevant for large and very large cubes. Requests greater than 0 partitions of 10 to 15 million, it can still handle. What it's saying is, even if I have requests which are not comprised of size 10 to 15 million, I can still handle. But if it is more than that, this can affect your merging process, so handle it. And inventory handling, a new info cube created for okay. Now for unoptimized cubes, you no longer works with DB indexes, statistics. See, normal cube, you do all kind of building index, dropping, DB statistics, and all those stuff, right? So in case of unoptimized cube, these are no more required. No more DB indexes, no more DB statistics, nothing is required. So in case of unoptimized cube, we still have the old processes, still having those processes, they do not do anything. You have to remove them, yeah. And in case of new, if it is BW on a HANA system, if you create a cube, automatically it is unoptimized cube. You cannot control it to create. These restrictions are no more. Don't worry on these restrictions. And if you want to deal with unoptimized cubes, with dealing with inventory management, this is the note to be referred, 1548125. So handling of inventory management with unoptimized cubes, this is a note, okay? Okay, boss. Yeah, tell me, any doubt on unoptimized cubes now? Yeah.
Sir?
Hello? Yeah.
Yeah, I mean, it would be a basic question. Please bear with me. We say that cube, right? The cube is a normal table in my,
yeah, it's another data target. Yes, like that. Yeah.
Yeah. When you say, when we convert a normal cube to optimized cube, is there any characteristics that we figure out that this is a normal cube and this is a, optimized cube?
See, in a BW or a HANA system, generally everything is in unoptimized cube, but you look at the symbol here, the icon. Distract 1 second. And by the time I show, there is a question from Saddam saying, what is BW index cube? Now, once we have the BW on HANA, no more, it does not support any BW accelerator. Once we have your BW with sitting on HANA, BW accelerator is not supported. No, we cannot connect to BW accelerator. No more accelerator. Okay.
Sir?
Yeah.
Sir, actually in document it said that in HANA optimized info cube will behave like a BW index info cube.
Will behave is different. See, there is actually a word, if you know BW, there is a concept called BW accelerator bus to speed up reporting, where my queue was holding the data and then BW accelerator was holding the indexes as a separate server. just to improve query performance. Now what they say now is once we have the HANA system, we do not need BW accelerator. It does not support BW accelerator. Now HANA itself will handle the query performance. That's what it means. Okay. Now, boss, for the other question, you asked me how to recognize. Look at the symbol here, the gray box.
Yeah.
This will tell me that this is an unoptimized queue. Yeah. Okay. Okay, boss.
One more question.
Yeah. Yeah.
When we are migrating from a normal info cube to a HANA optimized, so what are the transformations? Like you said, we have that T code where it will take care of all the migration. But what if there are any transformations and field routines?
See, that's what I told you, right? When the cube is getting migrated, no transformations, no DTP, no multiple will get affected. See, after the conversion of the HANA optimized cube, we just behave just as a normal cube before. That is, there is no need to change any load process, DTP, multiple, nothing to be changed. Okay.
So does it still support the field routines?
Yeah. Why not?
Okay. Thank you.
Yeah.
And sir,
So once let me finish this. Is there any concept of still we do not, since we do not have any dimensional table, so question very okay. There's a concept there's no concept of line item dimension because every characteristic is having SI in the fact table, then there's no point in line item dimension especially. Almost every characteristic is acting as line item now. Dimension. So we have aggregation concept, baby cubes, no aggregates. No concept of, once we have it on BW on HANA, we will not use aggregates at all, no more. And in fact, suppose you have a BW system which is running on SQL Server database and you want to migrate, as a pre-migration, we will deactivate all the aggregates. Before we migrate HANA, we will be deactivating all the aggregates because we want to reduce the space when it comes to HANA. What about data, sir? Will it merge automatically? Which merge?
After migration, what about the data? If there is a data inside the
You don't
cube,
have, nothing is taken, the system will take care about the data. You don't have to worry. Data is automatically. The analysis is limited here, right? Analysis means, what is this, Vinay? We had the same limitation, right? So I'm saying we had around 13 dimensions, each one supporting 248. Now we still have the same limitation, nothing more. Yeah. Okay. Raghu, tell me what is your doubt, Raghu?
my question is the remodeling technique, the functionality.
So sorry, voice is
Is it
breaking.
still
Sorry,
supported?
voice is breaking, Raghu.
Sir,
Yeah.
yeah. Remodeling technique. Is that still supports a remodeling function?
It will still support remodeling, but it will still support remodeling, no problem. Yeah.
Okay, sir. Thank you.
Lalkrishna here. In general, currently,
cube and one normal cube. Yeah, no problem. Now tell me. Yeah.
Yeah. I have a question here. In general, the clients currently, if they are migrating BW existing RDBMS to an HANA system, how they are going? Are they converting existing system to HANA, or they creating a new HANA server and bringing BW data to HANA?
If you get into the topic, it will lead to different results. But you remember I told there's a topic like database migration on HANA. So I'll take one session explicitly on how do we migrate the existing BW system onto HANA. Okay. If you can wait for another 4 to 5 days, we'll get to the topic in detail. Okay. Because there are multiple options. There's not like one option. One option is you do in-place migration. You use the same system and migrate their HANA database. Or we do sidecar implementation. You have the old system just like that and get a copy, then migrate it. So there are multiple options. We'll discuss on that. Okay. Yeah. If you can bear for another 4 to 5 days, we'll get to the topic.
Sir, I have one question pertaining to the BPC. When we create a model in BPC, automatically a cube is replicated or created in BW. So with 7.4, 10.1 composite sorry, embedded version, if I'm going to create a model, will it be created in HANA also, or how it works?
Not in a, see, BPC will never sit on HANA directly. BPC will sit on BW and BW application will sit on HANA, right? So when you create your model, it creates a cube in, still it creates a real-time cube in BW, and which will have corresponding tables in the underlying HANA database, okay? Previously they were having tables in other database, now we'll have the tables in HANA, that's all, nothing new.
Okay.
And when
automatically there will be a HANA optimized.
Yeah.
By automatically there will be HANA optimized cubes, real time.
Exact. Conversion of cube, do we do it indirectly in production? Conversion of queues, can we do it directly in production, or do we need to do it in dev and transport? Yeah. Basically, generally we will do it in development and then we will transport it. Okay. Generally, cube has multiple dimensions to organize data properly. Organized. That's what I'm saying. In if it is BW on HANA, you don't have to do any dimension analysis at all. Just నీకు ఎట్లా మూడు వస్తే అట్లా క్యారెక్టర్కి అసైన్ చేసాలి. Yeah, you can have this. Okay, next concept, HANA optimized DSO bus. See, actually what SAP has done is, initially when we had BW 7.3 with SP5, so while transporting, can we keep the data in production? Yeah, no problem with the data. Yeah, okay. Okay, was now with BW 7.3 SP5, initially when they came out with BW on HANA, they came out with some concept called HANA optimized DSO or in-memory DSO. Okay, but later due to some issues that was already taken out. So now there is no more concept of HANA optimized DSO or in-memory DSO. First, let's see what was that actually. If you look at the normal DSO, you will have, we know this, right? You will have new table, active table, and then change log. All the three are the tables. And then when you load data, data gets into new table, and then when you activate, which is the ABAP program, it takes from new table and writes it to active table and maintains corresponding entries in the change log. We know this normal mechanism of the classical ODS. Now they came out with HANA optimized DSO with this concept. They said we'll have activation queue. They'll only have two tables physical. One is new table and active table will be physical tables. And they wanted to maintain the changelog table as a calculation view. Okay, and the activation is still done with the C++ as the stored procedure in the HANA database. Activation process will be done in the HANA database. Yeah. Now we still use this concept for DXE, in-memory DSO. So when you load data, data gets into activation queue, which is new table, and then when you activate, it will be performed with the C++ as a program, as a procedure, and which will write data into active table. And the change log, it does not maintain any data physically because they won't eliminate the size of the change log. So the change log will not be physical. So what it does is, when you try to see the change log at the runtime, your active table will give the latest change. What it does is, in the active table, it only maintains something called history table. Within active table, it maintains something called history and latest change. So with that, it gives me before image and after image bus. See, for example, say you load one record with new one combination newly bus. Let's say that was with value 10. In the active table, it maintains that in the history bus. Then later you do a lot of changes from 100 to 20, 100 to 80, 80 to 50, then 50 to 30, then 30 to 10. So ultimately the value 100 was changed to 10 bus. Your active table history will have 100 and the latest value will be 10. Now when I try to hit the change log will read the history value and the latest value and give you before image is -100 and after image is 10. It does not worry about all the changes in between. It considers only the latest first change and the latest changes and gives you the logs. So because ultimately when the others are changed, I don't have to worry about the changes which are performed in the between. That is their logic. Okay. Now look at this. Your activation queue is like normal table. Your active table will have history storage, main storage, and delta storage. So you'll have special storage called history here. Okay. Look at this now. Let's say I have a document number with 30 and I have a document number with 20. First I load. So first time when I'm loading this document number 5455, that's the initial record. So that will be maintained in the history table bus. And then as what 30, then you load this with, then when the change happens to 20, you'll have the main will only have 20. Then calculation view is virtual. At the runtime, it takes the minus 30 as the history image and 20 as the latest image. If the 20s get changed to 5, 2, 3, 1, it just shows me minus 30 and 1 as after image. That's all. That is their plan. So where the change log was completely virtual bus. So they thought this would improve the performance, but this had a negative impacts on loading data to next level targets. So when I wanted to load data from this unoptimized DSO to the next level targets, since the changelog was not virtual, since changelog is virtual, it was affecting my loading performance. So they had this issue. So they said no more concept of unoptimized DSO. Let's switch back to normal DSO bus. So there's no more concept of unoptimized DSO or in-memory DSO. Suppose in 7.3 versions, if you have converted them to unoptimized DSOs, you have to reconvert them back. So SAP is no more supporting in-memory DSO bus. Okay. Now look at this. So there's a program given rsdri underscore reconvert underscore data. So this will be used to reconvert it to unoptimized DS. For example, if I go to the system is stuck, one second. Do you see any compatible? Not in this year, 2 years back already. Two ఉంటే 3 నాకు తెలిసి 2 years ఏంటంటే దానికంటే 2 నెలల ముందే వచ్చింటారు 2 years or 3 years. One second, is disconnected. Trying to reconnect back. Because I want to show you that option saying no more conversion of unoptimized DSO, then it will be suppose if you have converted them already, you have to remigrate them back to normal DSO bus, classical DSO. Why it is not connected? From 7.3 SP8 it was not supporting bus. Only in SP5 it was supporting it. I think it is not connecting. I can show the program, but there's a program called rsdri underscore reconvert underscore data store to basically reconvert the data. Suppose if the DSO is already converted as in-memory DSO, you can remigrate it to classical DSO by using this program. And for more details on not supporting of DSO, you can refer to this note 1849497. Okay. Now we'll discuss this tomorrow. Not to hurry up. Okay. So we'll stop it here and we'll continue tomorrow. Okay.